Hey everybody, this week I've spent a bit of time fixing up the inventory screen and some of the bullet collision stuff. They were the two main things I've done this week. One of the things you may be hearing is the music difference. So at the start of the week I went through pretty much all the music I've bought along my game development journey and just tried to find ones that suited the theme. I don't know if these are going to be the final music, but say this one for the intro. If you can hear, it kind of suits the theme of the game I want to go for better, so like dark ambient electronica music. So that was one of the first things. But yeah, I'll get into the inventory screen and demo that, and then some bullet collision stuff, and then go through a little bit of the bullet collision stuff in code. So that'll be this video. Yeah, so with the inventory screen this week, I'll add another one, add item 2x2. So I've just changed some of the test items artwork just for some variants to demo. Like these aren't going to be the game artwork, it's just for these. So I've got these images now separate so we can see some visual clarity on which items we have. So like, yeah, we have this one by one. We've got this new description section, the more detailed image. And yeah, these are all, well, this one and the planet are some artwork from previous games I've made, and yeah, that one I just made as a joke for now. So here we've got this new description area where we get like a demo image, a more detailed image. Here, like, yeah, so that's the size I'll probably keep. And then a description here, which is just a text description. And it's got text wrapping automatically. So compared to like in my patch notes menu, I've been manually kind of managing how long the strings are and new line when it gets to a certain length. Here I've just added an automatic text wrapping, so this is just one big block of text and it just gets wrapped based on the input width I've put in. So that's nicer and easier to manage. But yeah, what I'm probably thinking is adding a small section at the top there that just says description, so it's just the header for the description area, and that's just that new area. As well, another thing I added for the inventory is when you click away it deselects, so just another nice thing. And I was thinking like if you click away on the grid, but it's pretty much if you click away anywhere at the moment. And then yeah, clicking, and like I was gonna add the functionality, if you click and drag off here, it's gonna drop the item, but I haven't added. I didn't think to add that just yet because I'm liking it just to be like this at the moment. So that's most of the inventory stuff I wanted to demo. So I'll get into the bullet collision stuff now. The other thing I worked on this week was the bullet collisions, so fixing a few of that and the bullet position stuff. So like one of the things I was testing this week, I was standing in say this position testing a collision on this wall, and because I was only getting the axes of this wall, so this, let's say OBB, when I was doing a vector to OBB collision detection, because I was only getting those three axes, I wasn't getting, let's say if we fire here, we have a line that comes in this direction. We weren't getting the gap between, so this wall and here. So like, let's say that, because we weren't getting the two axes of the bullet, so let's say the velocity, which is one axis, the vector of the bullet's movement, and the other is the bullet's width. So because we weren't getting that, the separating axis theorem we were doing wasn't getting this gap. So because of that, all three axes, when you're standing in this position, let's say, would return collision, well, no gap found. So it would detect this as a collision, which is a problem. So that was one of the things I fixed, to include the bullet's velocity and the bullet's width as two extra axes to add to that calculation, which I'll demo a bit in the code and try and get up like a Photoshop explanation going in that section. But yeah, that was one of the things. The other thing was, when you fired the bullet when you were moving, you could notice, you probably see it in the previous videos, but you would notice the bullet would start at your next frame's position, so your future bounds position. And it was just when I separated the bullet from the player class, the update ticks were kind of out of alignment. So like, because there was three things, you had your camera position, your player, and your bullet. So I think what the order was, if I'm remembering, I updated the camera position and then updated the bullet and then the player. So the bullet was also basing its start position on the camera's position. So like when we're moving, the camera would move one frame ahead, the bullet would fire, meaning the bullet would start in the next frame's position, and then the player would update to that position. So yeah, like it would look a bit wrong. But if I'm firing now and you see the bullet's position, like if I'm moving to the right here, I don't know if the video will pick up on it, but if you see there, the bullet is to the left of the cursor. It's probably really hard to see in the video, but that's now expected, what I'm expecting it to do, because at the moment I'm not including player's movement velocity in the bullet's result vector. So like if we're here, the bullet will fire in this direction. Next frame we're here, it'll fire in this direction, but we're not including, like if I'm moving here, we could include like this frame's player movement into the result of the bullet. So it's not going to be moving directly straight, it'll move like slightly in that angle. So I may include that. I just want to learn the correct physics behind when a player is moving. I'm pretty sure, yeah, real world physics will include your own velocity in the result of the bullet's movement. And that, yeah, that would look even in the game correct. But yeah, I just want to do a bit of research first before I add that functionality to make sure I'm doing it correctly. So that's the last thing with the bullets. So yeah, they're looking a lot better, and as well, if I go very slow time, we can see that a bit better too. So now you can fire at normal fire rates when you're in slow time as well. Just for testing, I don't know if I'll keep it like this, because it would make slow time even more overpowered in the game. So yeah, like you can fire all the bullets. But yeah, it's better for testing that I can see, and like mainly when I was doing this, like you can see what bullets will collide with the wall and what won't. There. So like even if it just skims, it shouldn't collide. There. So yeah, just for collision detection stuff. And then yeah, that was the other thing fixed when you were firing down in slow time, it wasn't basing off the slower velocity, or I guess in any direction, but it was most noticeable when you were looking down. But so when it was doing the collision detection, I was basing the result vector off the full velocity, but in slow time the velocity is a lot slower, so the velocity is also based on the current time interval as well. So like this slow time, so yeah, you can fire down properly and it detects the collision point correctly and all that. So that's all was fixed this week. So yeah, I'll get into the bullet collision code a little bit. I won't go into detail much. I'll just kind of explain what I'm doing and then yeah, show a bit in Photoshop. I'll go into code the OBB to vector, well the vector to OBB collision detection I was doing, which was just this. I'm recording in desktop mode as well, so it may be a little bit laggy, and that's because I want to switch from Visual Studio to Photoshop to explain a bit better. So yeah, I was only getting these three axes, which is the OBBs. So let's call the OBB the wall. So we're only getting the wall's three axes, which was a problem. You also needed to include so because I'm doing the velocity, which is the change in the moving model, so comparing this to OBB to OBB, you just get the two OBB's axes. So if we go here, we're getting, like we've got OBB1, OBB2, we're getting all 6 axes, and that's just doing the projection calculations on those. But with velocity, or with a vector, we get the OBBs plus the velocity plus the width. So let's say this is the bullet, we've got the wall and the bullet. One extra axis is the bullet's velocity, which is the movement, and then this time dilation is just simply like, if it's normal time, this is 1, if it's very slow time, that's 100. So it's just the divisor for most of the game stuff. So we can effectively ignore this for just this demo. But let's say we have a bullet velocity of 1 meters per second, and it's only going in the x-axis. This would just be like 100. So that's it. Its movement is an axis on itself, and then the other axis is just the width of the bullet. And this is just, so this upper top left, upper top right, this is all calculated in my OBB class. So this, yeah, is not implemented in MonoGame. You have to build your own OBBs. So here we're getting upper top left and all that, and this, we're just getting the vertexes of the object. So this is used throughout the game to do, yeah, where the player is interacting or colliding with a OBB, things like that. So in this case, we're using it for just getting the width of the OBB, so the bullet. And this we only need to do this once for this collision, so that get vertexes, we're not calling every frame because the width of the bullet should always remain the same. So upper top left minus upper top right, regardless of what position it is, should always be returning the same result. So that's the other axes we're calculating there. So that was the other thing. We've just needed to add those two to our vector to OBB collision. So I'll show that in Photoshop now. So like if we have a wall here, this is the wall that we saw before, and then we have a bullet. So let's say this is the player position here, and then let's just draw it red. Something like that. So we have, this is the, yeah, that's not good actually. I'll just draw it by hand. maybe not. Go 10. So this is the direction the bullet is traveling in, like that. We'll just erase a bit to make it look like a bit. So here we have the player's position, we have the wall, which is the OBB, we have the bullet, which is the moving model. Now, when you're getting the vector to OBB, I'm not just getting the current position. So like what we're doing, I'll go a different color. So if we're doing bullet to wall collision, which is OBB to OBB, we would be getting like bullet's position at this point, at this point, at this point, at this point, and that would be straightforward. We could use the OBB to OBB, but what we're doing is getting the vector to OBB, which is the bullet's delta position between the frames. So like frame 1, we're getting the bullet's position here to here. So we're getting this vector. So what we're doing is a collision detection of this vector to this wall. So when we're doing separating axis theorem on this vector to the wall, what we're checking, if you haven't seen the previous videos, so in this case we've got a 2D version, but we're getting, so this wall's projection on its y-axis is that. This wall's projection on its x-axis is that. Right? So there's two projections we're getting on this wall's axis. We also need to get this vector's projection on this wall's axis. So this vector's projection on that wall's y-axis is that, and this vector's projection on that wall's x-axis is that. So because there's a gap here, we know there's no collision. But let's take, in the example I was trying to show before, we have a vector that looks like this. I'll go a different color. Let's go green. So let's say we have a vector that looks like this. Now the projection of this vector is, actually it needs to look like this. So when it was high velocity. So like let's say we have a vector like that looks like that. So the bullet in frame 1 position was here, the bullet in frame 2 position was here. So the result vector would be something like this. Now what was happening is we were only checking the projection on the wall's axis. So we know this wall's axis is from here to here, but this bullet's projection on those axes was from here to here, right? And then on the y-axis, its projection was from here to here. So because of that, both projections, so this and this, the blue wall projection on the y-axis and the bullet's projection on the wall's y-axis had a collision, or had a crossover. So there's a collision on that axis. Same with this. So because of that, it was detecting a collision. So why you need to now also, and this was my mistake, to not include the bullet, even though it's the velocity, you still need to include, say, the width. So we're getting, what we need to do as well is get, I'll go a different color again. We also need to get those two axes, which is this one. So the bullet's velocity projection on its own axis, well, yeah, on the bullet's velocity axis is the same. So we know that. And then we know the wall. So the wall comes from this y we know it'd be from here to here. That's the wall's projection on this bullet's velocity, and from here to here we have on this, so it'd be from here to here. So I can't really draw this, it'd be like that. So we'd have a collision there too. But what we need is, we need to find, I'll go another color. We need to find this gap from this wall to this. So this was the problem we were having before. We need to find the gap between the bullet and the wall, and with that you need to get the width of the bullet. So the bullet here, the projection of the bullet on its width axis, let's just call it the width axis, is this, and then the projection of the wall on its this width axis, so on here it's from here to here, so there's a gap on that one, same with this gap. So because of that gap, this will return false, meaning that there's no collision, and that was the missing link in the bullet collision detection stuff. So, and that's, yeah, the same separating axis theorem, which is we're getting the projections on every axis of the two objects and then checking if those two, so the bullet's projection and the wall's projection on that axis, if there's a crossover, then we return true. If there's no crossover, like in this case, we return false. And if any of those return false, then no collision has occurred. So yeah, that's again the basics of separating axis theorem and the problem I was facing there. So yeah, that's the one thing I wanted to demo in code, and hopefully that gives a better explanation. So yeah, that was everything I wanted to demo. So yeah, thanks for watching. That was everything I wanted to show this week. That's everything I'd worked on, so the inventory screen and the bullet collision stuff. This next week I'll probably still be working on the inventory. There's, yeah, that title, and I want to start adding the UI for those 10 inventory slots the player has, and then work on integrating that inventory screen with your active equipped stuff, so those 10 slots. And then, like, so currently you've got this equipped weapon, it needs to exist in the inventory and it needs to be set in, say, your slot 1, and then probably even the droppable stuff. So yeah, this next week I'll probably be working on that. But thanks for watching, that's it.